Hi guys, today we will be doing the EE200 Radio Lab. I myself the host, Seren, and we have Erkut. So we both will be doing the lab today, and Erkut will be helping me with the cameras and setups. So we'll first start with what are the setups for the radio lab. So basically we can so So the radio lab is basically an implementation of how a radio station works. So as a radio station works, you know all radio station. There will be a RJ which will transmit a music or some kind of audio signal which is actually AM modulated, and the AM modulated signal is transmitted. So that's what's happening over here. We have an audio signal which is AM modulated and then transmitted to the antenna, which is their main antenna, which is received by our antennas at our homes, and then we will do a demodulation on the AM signal and amplify it, and we'll hear through the speaker. So this is what our intention of our lab is. Basically we'll go to the circuit implementation for the radio lab. As I said in before, the first part of the circuit in this, we will pass an AM modulated signal which will be then connected to a band pass filter which is centered at 175 kilohertz, then amplified around something 60 volt per volt, then demodulated with an amplitude demodulated using a envelope detector or peak detector circuit. Later on it is then passed to a decoupling capacitor so that all the DC offsets can be removed and then amplified. So this is the basic working for this circuit. Now moving forward, we can see how the output turns out to be at each and every stage. Now I'll first start with the AM modulated signal. This is the oscilloscope. Along with it we have the function generator also. The carrier frequency is set to 175 kilohertz with the amplitude around 2 peak to peak. I'm initially using around a large value so that I can see the outputs at the second stage. Then in order to do modulation, go to modulation. You can just on and off here. With this you can turn on the modulation or turn off, and here you have AM, the different modulation schemes. You have AM, FM and FSK. I'm using AM modulation because the initial radio systems worked on AM modulation, and the input frequency is kept around the audio frequency range, and the depth is the AM depth. So first start looking at the input signal. This is the input signal. So this is the AM modulated signal, you can see. So in the positive half and the negative half, the negative cycle and the positive cycle carries the message signal, and in between it's the carrier signal that is which is modulated at 175 kilohertz. Sorry. Now this AM modulated signal is then passed to a band pass filter which is centered at 175 kilohertz. So the output of the band pass filter is this. Now you can even test it. I will increase this. Now you can even looking at the amplitude. I'm going to change the frequency of it. If I start increasing the frequency, there's a rejection coming out. That is why the amplitude is reducing. Now if I decrease the frequency from 175 kilohertz and onwards, you can see that it's again rejecting it. So it's a band pass filter which is around centered at around 175 kilohertz. So the peak amplitude is around in that range. Now after this, so I'll set it to 175. After the signal is transmitted, it's filtered at center frequency of 175 kilohertz. The next part is we will amplify the audio signal. Along with the modulated signal, we will amplify it. The amplification that we have chosen over here is around 66, 65 volts per volt. You need to get more than 65 because the voltage coming from the antenna is around in microvolt, but it's just for lab base, you can choose a low voltage. Since the voltage is transmitted from the antenna is not that small, that is why I have chosen as around 66, 67, but actually we need to have more than 100. Now the amplified version of the amplified version is this is what you can see right now. It's a 3-stage amplifier, and we have used TL081 IC. So basically it's a 3-stage, we have used, you can use any combination because you can take 2 inverting and then non-inverting so that you get the same, the phase difference is 0 degree or 360 degree. So that's what our idea is. So you can use 2 inverting and 1 non-inverting, or you can go for 2, just you can say 2 inverting means you can go for an inverting, non-inverting, no, you can take 1 non-inverting and 2 inverting, that will also work. So ultimately you have to make sure that your phase difference is actually 0 degree or 360 degree. The amplified version of this is what you have seen right now. So this is the amplified version of the AM modulated signal. After the amplification is done, we need to demodulate it. The demodulation is done using an envelope detector or peak detector. You can take the upper half the signal or the lower half of the signal, because both are your passage signal, so you can take either one of them. We are choosing the lower one, the output of the demodulated signal. Is this is almost kind of a sine wave, because the wave that you got from here, that is this power portion of the wave is actually being transmitted. So I'm just taking this portion of the wave because it's clipped, that is why it's going down. Now after this I'm going to amplify it. So basically the amplification I've used very large, so that because the audio signal coming from the outside part is the audio signal is actually needs to be amplified a lot, that is why it is clipped in this case. But when you connect it with an audio signal, since the voltage is very small, it will not be heard properly. That is why in this I have made sure that it clips off properly. If you want to check it, you can just reduce the amplitude of the input signal, but since I have clipped it, I have provided a voltage such that it clips. So the basic idea is that I know that the voltage is, if you just reduce it, so when it's just reducing the input signal, because it's somewhere in millivolt range. It's less than millivolt range. The basic idea is that I know that the voltage coming from the audio signal is a very less than it's in millivolt range. That is why I made sure that the output stage is clipped so that you can hear the audio signal properly. So this is the output of the this is the output of your radio lab. So now what I'll do is that I will test this circuit with actual implement. I'll transmit an audio signal and modulate it and transmit to an antenna, and then this circuit will demodulate it and will be passed to a speaker. So this is the implementation part of this will be shown right now. Okay, now we'll go to the last stage of the circuit, is that we will test it with an actual radio station. We will play a music which will be AM modulated, amplified, and which will be the audio signal will be amplified, then AM modulated at 175 kilohertz. You can see from here, this is the audio signal. I'll be playing music. This music will be which will be amplified over here, which is a simple non-inverting amplifier, and then this audio signal is then modulated. You can see over here we have used modulation. So here the frequency is modulated at 175 kilohertz, and this modulated signal is connected to the antenna over here. This is a transmitting antenna. This transmitting antenna is then received using a loop antenna over here. This loop antenna is then connected to a circuit that we had built before, and the output of the circuit is then connected to the speaker to hear our audio signal. So this is the full setup, just like how a radio station works. Now I will just play the music. So you can hear that I've played the music of Beethoven, and you can hear the audio signal. So this is how the radio circuit needs to be built, and this is how the full setup works.